Example 13.3, a small star is placed at the origin of this coordinate system. We want to calculate the net force on this star due to its gravitational attraction to two nearby stars positioned as shown. So this basically boils down to calculating the magnitude and direction of F1 and the magnitude and direction of F2. The directions are easy, however, because the gravitational force always acts along a line connecting the centers of the two masses. So F1 points directly towards this star and F2 points directly towards this star. The magnitude of the two forces can be obtained from Newton's law of gravity, equation 13.1. Once we have these two forces, we can add them vectorially. We'll do that by breaking them into their components. So let's begin with the magnitudes of the two forces. So the magnitude of F1, of course, is just the product of the masses times the gravitational constant, shown here. And I need the square of the distance between here and here. But this is a right triangle. And in fact, these two sides are equal, and this is going to be 45 degrees. So I just have to square the two sides and add them together in the denominator, and here's the magnitude of that force. F2 is a little easier because the distance is just from here to here, which is 2 times 10 to the 12 meters, and I plug that in, and I get this force. Now I need to break them into their components. Again, going back to F1, the angle is 45 degrees. So here's the x component, here's the y component. F2 has only an x component and no y component since it lies on the x-axis of this coordinate system. So here are the two components of the net force. I just add up the components of F1 and F2 respectively, and I can get the magnitude of that force as shown here. And finally, I can get the angle that it makes with respect to the positive x-axis, and that's going to turn out to be 14.6 degrees. It is interesting that this angle does not point towards the center of mass of this two-star system. Both of these stars have the same mass, and so their center of mass is right in the middle. If this pointed towards the middle, then the angle would have been 26.5 degrees. And this ends example 13.3.